Yeah. For this video, I'm going to solve another problem about beam stresses. Here's the problem. Determine the maximum bending stress, the maximum shearing stress due to V or shear in the simple supported beam shown in the figure. And let us see the shearing stress at a point 1 meter from the right support and 3 centimeters below the top. Okay. So first is to solve for the reactions. So let's denote this one as R1 and then this one as R2. Okay. And let's draw first lines for our diagrams. Okay. So step one. Uh, step one is another. Solve for the moment of inertia. Okay. Moment of inertia. Okay. Since this is a rectangle, the moment of inertia is 1 over 12 BH cubed. So it's 1 over, let's use millimeters, values in millimeters. So 1 over 12. Our base is 6 centimeters. So that would be 60 millimeters times our height, 160 millimeters cube. So that our unit will be in millimeters raised to 4. That's 1 over 12 times 60 times 160 cube. That's 20.48 times 10 raised to 6 millimeters raised to 4. So our first step here is step one. Second step is solve for the reactions. Solve for the reactions. Okay. Okay. Let's solve for R1. So we're going to sum up moment about 2.2. Counterclockwise moment as positive. So for the uniform load, you get the resultant. And the resultant is 10 times 2. So 10 times 2, that's 20 kilo newtons. So sum up moment about 0.2. 20 is positive counterclockwise. So the distance is 1. 1 is 1. And the given couple moment 10 is clockwise and negative minus 10. No distance kay moment naman. And then the moment of R1 is negative also clockwise. Negative R1 times distance 4 equal to 0. So R1 equals 20 times 1 minus 10 minus shift solve then. Shift solve 2.5. kilonewtons upward. Okay. And then summation of force along the vertical y, R1 2.5 plus R2 minus resultant 20. And R2 is 17.5 upward also. Okay, so from the values computed, we can now draw the diagrams. This is 2.5 and this is 17.5. Okay. So if we draw the shear diagram, this one, shear diagram, from this point up to the support 0, so R1 upward ka, 2.5. So you have 2.5. Tapos from this point up to this point, no load, so horizontal. So 2.5 yapon eh. And then subtract this load 20 na. Negative kay downward. So 2.5 minus 20, you have negative 17.5. So maybe this one. Okay. This is negative 17.5. And then you have this reaction upward. So mag-close na siya. This is your shear diagram. Okay. We have this point where shear is 0. So draw tag line here. Let's solve for this distance x. Okay. How do we solve for x? It's just ratio and proportion. So step 3 here. Then na lang. Solve for x. Solve for x. It's just ratio and proportion. 2.5 is to x. No? 2.5 is to x. 17.5 is to 2 money. 2 minus x. 17.5 is to 2 minus x. So, makuha ni mo x na. Input ni mo na dali. 2.5 is to x equals 17.5 is to 2 minus x. And shift solve. That's 0.25. Dugay man sa. Wait. 17 shift solve x 0.1 example 0.25 okay. The reason why nga naka-answer ko in advance kaya I have my own technique. So my technique or my shortcut is this. It's very simple. To solve for x, you just divide this one 2.5 divided by the uniform load. So 2.5 divided by 10, that's 0.25. So, mas dali akong shortcut. So, instead na mag-ratio and proportion, pwede yan eh. 0.25. Okay. So, natin x 0.25 and we can now draw the moment diagram. Okay, so let's draw the moment diagram. Moment diagram. Okay. This one has an area of nasa area na 2.5 times 2. So it's very easy. That's 5. This one, the triangle is 1/2. Okay. That's 1/2. Oh, sorry. 1/2 times x, which is 0.25 times y, 2.5. That's 0.3125. So the area is 0.3125. 0.3125. Now, for this one, this is negative, di ba? The area is negative. 1/2. 1/2. Ang base niya is 2 minus 0.25. No? This is 2 minus x man. 2 minus x times y niya, 17.5. 15.3125. So this is negative. Dali na lang. Area is negative 15.3125. No? Negative 15.3125. Negative, negative. Okay. So, let's plot the moment diagram. Ang load na 10 is clockwise na siya. So, there's a sign convention na pag clockwise ang external moment, positive na pag clockwise. So, i-plot na to as positive. 10. Here, no? Natay 10 dire. And then, sa shear diagram, since wala area, so horizontal lang ta. Okay, so 10. And then, mo add tag area ni 5. So, natay 15. So, natay 15. No? And then, mo add tag ng area, 0.3125. So, pag ang diagram is this one, ang curvature sa moment is concave downward, concave upward going down, but since positive man, i-mirror na siya. Concave upward going down, i-mirror, mo na yung forma niya. And this is second degree, and the value of this is 15 plus this one, 0.3125. This one is second degree. Second degree. And then minus this one, negative 15. So mag-zero na siya. Ang curvature niyan is from first degree to second, concave downward, going down. Hinani ang diagram. Second degree also. So this is your moment diagram. Now, so step 4 is one, to determine the maximum bending stress. Sorry, step 3. Determine the maximum bending stress. The formula is sigma equals MC over I. And let's substitute the values. The maximum moment is this one, 15.3125, and the unit is kilonewton meter. This is our maximum. 15.3125. So that we will have a unit of megapascal stress. All units will be expressed in newtons and millimeters. So 15.3125 will be converted to newtons millimeters. So i-convert niya siya, mag-multiply ta 1,000, i-convert siya ni meters, another 1,000. And therefore our moment is 15.3125 times 1,000 squared. Moment lang na, ano? Tapos, ang C na to is 1/2 sa height. 160 millimeters, so 80. And our I is 20.48 times 10 raised to 6. And we have our maximum bending stress. 15.3125 times 1,000 squared times 80 divided by 20.48 exponent 6. 59.81 mega Pascal. Okay. This is our maximum bending stress. Step 4. Determine the maximum shearing stress. Okay. So the maximum shearing stress, the formula is this. Tau is VQ over IB. Now, the maximum shearing stress is located at the neutral axis. So, and V is the maximum shear, which is 17.5. 17.5. This is our maximum shear. Ang unit ani is kilonewton. So, let's compute for Q. Okay. So, neutral axis man. So, mag-cut ka dire sa center. Like this one. And this is our neutral axis. Ang dimension niya in millimeters you have 60 and 1/2 sa 160/80. And ang centroid niya is nasa center. So ang Q na to, ang pag-solve sa Q is area times Y. And that's 60 times 80. Muna itong area. Ang Y is distance centered from the neutral axis, and that is 40. So, we can solve for Q. 60 times 80 times 40. That's 192. thousand millimeters cube. Ano atong cube? And so we can now solve for the shear stress. So maximum. Our shear is 17.5. Just disregard the sign. Times 1,000 conversion from kilonewtons to newtons. So this is our shear, and our Q is 192,000. Our I is 20.48 times 10 raised to 6. And our B with sa cutting section, this one, no? That's 60. Okay, so we can now solve for the maximum shear stress. 17.5 exponent 3 times 192 exponent 3 divided by 20.48 times 10 raised to 6. Yeah, 60. 2.734375 mega Pascal. Okay, so this is our maximum shearing stress. Okay. Sa step 5, okay. Okay, sige. Step 5 na lang. Step 5. Shearing stress. Determine the shearing stress at 1 meter from the right support. Okay. And then 3 centimeters below the top. So first, we get the value of shear, 1 meter from the left support. So example, 1 meter, i-project na nato there sa ubos. Okay. What's the value of this one? V. Pila value ni shear? You can do ratio and proportion. Like, okay, sige. 1 man yun, di ba? 1. Okay, so this is 1. 1. 1, 1. And since our x is 0.25, kini na distance is 0.75. So we can repeat this one. 2.5 with known x. Kini ang unknown, y. Kini y. And ang x na to is 0.75. So like this one. Yeah. 2.5 is to 0.25. No? 2.5y is to x. 0.25. Equals, ang ano na to y. Or alpha x. Yun unknown. I-divide na to sa horizontal distance, which is 0.75. 0.75 na. Okay. Shift solve. Sorry. Over 0.75. Shift solve. 7.5, no? So Our shear is negative 7.5. No. So that would be our value for V. Ang Q na lang. Okay. Sa Q, our V is 7.5 kilo newtons. Okay. Sa Q, yan yung Q. This is our cross section. 60 and 80. But then the fiber is 3 centimeters or 30 millimeters below the top. So, for example, the 30 na siya. So this will be our area. Okay. Our Q will be 60 times 30. That's our area. And ang center is sa center. So that would be 80 siya. 80 tapos 30. So this will be 50. 50 plus 1/2 sa 30. So y is 65. Distance sa centroid to the neutral axis. So that's 50 plus 15. So our Q is 60 times 30 times 6.5. That's 11,700. Okay, millimeters cube. So we can compute for stress. Stress, same formula, no? So we'll substitute value 7.5 times 1,000 shear ni V times Q 11,700. Okay. And divided by I 20.48 times 10 raised to 6. Ang B na to, dito nagka 60. So, our shear will be 7.5 times 10 raised to 3 times 11,700 divided by 20.48 times 10 raised to 6 times 60. That's 0.0714 mega Pascal. Okay. So, okay. So this is the solution for this problem. Oh, I hope that you have learned something from this one. Thank you for watching.